All right, welcome everybody. I'm very excited to have two gentlemen that are sitting in the lab over at the Tel Aviv University. They're part of the team with Element, building some amazing technology for the AR glasses and AR surfaces coming into the future. Now, I want you guys to kind of walk everybody through your background and just to kind of give us a little like laying out the field. So Ori, can you share a little bit of background about yourself?
Yeah, hi everyone. I'm Ori. I did my PhD at Tel Aviv University's lab. He's going to introduce himself in a minute. My background is physics and electrical engineering. And I've been working on these metasurfaces, optical metasurfaces or flat optics for the past 8 years or so. And yeah, Tal, maybe you can introduce yourself and then we can continue.
Okay, thank you, Ori. So hi, everybody. I'm Tal Ehrenbogen. I'm the head of the laboratory for nanoscale electro-optics at Tel Aviv University. And what we do in the lab, basically, we are interested to study how light interacts with the nanostructures. We are interested in the fundamentals of this interaction and also how we can use this new understanding in order to control light better. And one of the part of the research that we are doing, which was actually Ori's PhD, we wanted to construct these flat optical elements, flat nanostructured surfaces, in order to control different frequencies of light independently in transmission and reflection. Basically this is, along the way we understood that we have some new maybe technology to control light, and things basically progress into technological development.
Right. Yeah. So let's talk about that. Like Ori, you said you've been working for like 8 years in the lab, but you know, walk us through specifically with the metamaterials and the research that you've been doing with that. How did that specific project get started? Was that part of something else and then you decided to go into a different direction? Walk us through how this whole thing got started.
Okay, so we started studying, like fundamental science related to light matter interaction at the nanoscale, like Tal said. And basically we started developing these optical elements for all kinds of purposes, not specifically for industry purposes or AR, but we did some beam shaping and other types of elements. But basically there is a fundamental problem with these flat surfaces, that they have a problem working with different wavelengths, right? Usually they work very nicely at a certain wavelength or a certain color, but working with different colors on the same surface is challenging. So there are many groups in the world working on metasurfaces for, let's say, for more than one wavelength, okay? To work with more than one wavelength, it's called chromatic aberration correction. You want to correct problems that are coming from working with different wavelengths. And we thought of a solution of how to work with RGB, right? Red, green, and blue, that will work nicely in reflection and transmission, like Tal said. And again, it started like a project in the lab. And we had some nice publications and a nice impact on the academic community, let's say. But yeah, let's say towards the end of my PhD, we saw the potential in augmented reality. The reason we saw it is because our elements are transparent, which is, of course, very good to have when you're talking about augmented reality. And also we can control RGB, right? We can control the wavelengths coming from the micro display in augmented reality application. So we thought that this is going to be very good for this application. And yeah, and things rolled out from there. We joined a competition in SPIE Europe, and we won first place for augmented reality design. And from there, yeah, things rolled.
Nice, very cool. So I guess building something like this, you're essentially taking something and then building like it out of nothing. Like essentially that's what you're doing from the lab, coming up with these new discoveries. Maybe you could share with us, what are some of those like technical challenges that have come along with, you've already figured out how to do that, but also pulling that into a product. What have been some of those technical challenges? And then maybe some of the other like non-technical stuff that has prevented you from getting a lot further than you have.
How do you want to answer? Or?
I can start, maybe you can continue. Because we are doing nanostructured elements, so these are tiny, tiny elements, and each surface has millions of elements. A technical challenge is to fabricate these elements over large surfaces. So it's not, when we are doing an academic publication, usually we need only a small piece just to study the optical properties. But in a device, in glasses, you need to cover the entire surface. So this is one technical challenge that we had. And basically we developed a method to fabricate for research purposes. For industrial purposes, it is something that can be done. Yeah. But for research purposes, in order to develop the surface better, we had to find a way to fabricate over large surfaces. So this is something that Ori worked a lot on and was able to do. And now we have these large centimeter scale and more larger that we can do basically at the academic facility and study and develop these surfaces. So this is one technical challenge that we had. Do you want to add more, Ori?
Well, I agree. This is maybe the main issue when you start a project in the academia. So moving from academia to industry, let's say, going to large-scale fabrication and so on. So this is a major challenge, right? Fabricating large-scale samples that we can we can measure the properties and so on. So this is a major challenge that we have. One thing I can say is that fortunately in the university we have a TTO, Transfer Technology Office, that worked with us from the beginning of the project. It helped us with with connections with industrial partners or other sources, and this really helped us to get this project from, let's say, just a project in the lab to a project that can go further to a real product.
Yeah, I would like to talk a little bit more about that. So you said they started from the beginning of this project working with you, but perhaps like for them, not every single project is going to go and be a success. At what point when you were working, did you find out like, oh, we have something here, like this is something really special?
Actually, they found us. So.
Oh. How did they find you?
Tal?
So before they found us, Ori mentioned the design competition. After the design competition, we basically, with the TTO office at Tel Aviv University, we were able to raise a startup fund, seed fund, to develop the process. So it was a generous seed fund that allowed us to make a better development, to show a demonstration, a proof of concept demonstration. And close to the end of this phase of development at the university, we started to check interest by industrial partners, and things rolled out that Daniel came to our lab, and they got really excited about this technology, and we kind of hooked up and decided to take it to the next level.
That's so awesome. I'm just like amazed how everything's starting to pull together for the company, and I'm so honored to be a part of it. I guess like now, you're at this point right now where you're starting to build this company. What sort of advice do you have for other, I guess, other people that are doing research in this area? Maybe they're looking for partners, they're looking for people maybe on the other side of the globe. You did a competition. What are some of those other things to help researchers get connected with other people to help them build these solutions? Do you have any tips for anybody?
Well, I think the most important thing, we see it in the last 3-4 months since we met Daniel, is one of the most important thing is to find someone, an entrepreneur in the field that has like experience in the field, that knows the market, things that are, we are technical guys. We know about the physics and stuff, but in order to start a company, you need to have like a holistic or a different view of things, that people, entrepreneurs that work with new companies, develop new companies and new startups, they have this view of things, and it really helped us focus on what we should do, where we should go from now, and so on. So I think this is a key point. Partner with someone that has experience in this field, that has experience in starting companies.
Nice. Tal, do you have anything to add to that?
Basically, I agree with Ori. Also, if someone has this entrepreneurship spirit inside, I think that it can also something that can happen within the lab, like someone finishing research and wants to bring it into, so it can be self-sustained. But Ori is right that if you partner with someone with experience, you make a big leap forward, and you save a lot of learning process that you have to do yourself if you want to do it.
Yeah, that makes a lot of sense. Like if I wanted to invent a nano gas material where you would just look through the air and then you see different types of light, I would probably need to connect with like a really amazing physicist. I'm not going to be able to figure that one out. I can't Google enough.
Yeah.
All right. Well, guys, thank you so much. I know you need to get back to the lab. Again, I'm really excited to see what is going to come up with Element in the next couple of years. I know it's going to be massive. So thank you so much.
Thank you.
All right, thank you.
Have a nice day. Bye-bye.
Casey. Bye-bye.